Hi, my name is Miss Rizzo. This will be a student-facing video in which I will teach you about squares and equations. This lesson is loosely based on Algebra I, Unit 7, Day 5, Lesson 3A, Squares and Equations, but has been considerably adapted to meet the needs of students in alternate assessment high school classrooms. Much of the original lesson has been altered for this purpose. Algebra, squares and equations. Focus question. How can we use the properties of a square to help us find missing information in an equation? The next generation standard addressed, which is the same standard that was addressed in the original lesson, AIA REI 4B. Solve quadratic equations by inspection, taking square roots, factoring, completing the square, the quadratic formula, and graphing. Recognize when the process yields no real solutions. If you are like my students, you may have encountered questions about operations in algebra on formative assessments. So let's explore this topic more. Vocabulary that you need to know for this lesson. A square is a geometric plane shape with four sides of equal length and four right angles. An equation is a mathematical statement in which two algebraic expressions on both sides of an equal sign have an equal value. Area, the amount of space within the boundaries of a flat shape. So these are some examples of squares in real life. We have windows that are squares, a checkerboard, we have square graham crackers, square post-its, squares within a fence, square tiles on the ground, and the squares on the face of a Rubik's Cube. What are some other examples of real life squares you can think of? I would pause on this slide and have a conversation with your classmates about this to see how many other examples of squares you can come up with. So what do we already know about squares? A, squares have two shorter sides and two longer sides. B, all four sides of a square have an equal length. Or C, squares are three-dimensional shapes. So let's explore these options. A, squares have two shorter sides and two longer sides. So if we're looking at a shape with two shorter sides and two longer sides, we would not be looking at a square. We'd be looking at a rectangle. B, all four sides of a square have an equal length. That sounds right, but let's explore option C. C, squares are three-dimensional shapes. Squares are actually two-dimensional shapes. There's a three-dimensional shape that looks like a square because it has squares on its faces, but we call that a cube. So our best answer here is B. All four sides of a square have an equal length. The area of a square equals the length times the width. Remember that in a square, all sides are the same size. That's what equal means. So the length and the width will be represented by the same numbers. If you know the area, you can determine the length of a side of the square by determining what number multiplied by itself would produce that area. So let's explore some questions. If the area of a square is 25, what is the length of a side? So A, the length of a side is 7 because 7 times 7 equals 49. B, the length of a side is 3 because 3 times 3 equals 9. Or C, the length of a side is 5 because 5 times 5 equals 25. So we know that we want both sides to be the same length. So in all of these equations, 7 is multiplied by 7. It's multiplied by itself. So we know these sides have the same length. 3 is multiplied by 3. So both of these sides have the same length. 5 is multiplied by 5. So both of these sides have the same length. But which equation gets us to the area of 25? So for A, 7 times 7 equals 49. That cannot be the length. The length cannot be 7 because we are not looking for an area of 49. B, the length of a side is 3 because 3 times 3 equals 9. We're not looking for an area of 9. We're looking for an area of 25. So here, our best answer would be C. The length of a side is 5 because 5 times 5 equals 25. If the area of a square is 36, what is the length of a side? Let's explore these answers. A, the length of a side is 6 because 6 times 6 equals 36. B, the length of a side is 4 because 4 times 4 equals 16. Or C, the length of a side is 2 because 2 times 2 equals 4. So we're looking for an area of 36. A, the length of a side is 6 because 6 times 6 equals 36. That sounds right. Let's explore the other answers. B, the length of a side is 4 because 4 times 4 equals 16. That doesn't work because we are not looking for an area of 16. We are looking for an area of 36. C, the length of a side is 2 because 2 times 2 equals 4. Once again, we are not looking for an area of 4. We are looking for an area of 36, which must mean A. The length of a side is 6 because 6 times 6 equals 36. If the area of a square is 100, what is the length of a side? A, the length of a side is 5 because 5 times 5 equals 25. B, the length of a side is 10 because 10 times 10 equals 100. Or C, the length of a side is 6 because 6 times 6 equals 36. So we're looking for a total area of 100. So it cannot be A, the length of a side is 5 because 5 times 5 equals 25. It might be B. The length of a side is 10 because 10 times 10 equals 100. That's accurate, right? Let's take a look at C just to make sure we can eliminate it. The length of a side is 6 because 6 times 6 equals 36. That doesn't work. So our best answer here is B. The length of a side is 10 because 10 times 10 equals 100. So I would pause here and have another class discussion to talk about what did you learn about squares today? What did you learn about equations today? And what did you learn about area today? So just for review, this was a student-facing video in which I taught you about squares and equations. This lesson was loosely based on Algebra 1, Unit 7, Day 5, Lesson 3A, Squares and Equations, but has been considerably adapted to meet the needs of students in alternate assessment high school classrooms. Much of the original lesson has been altered for this purpose. Thank you for watching.